Okay, so welcome to this video on the DCG DEB mock exam from 2014. Dihedral angles. Look, there's a fair chance dihedral angles will come up on your mocks, so it's worth knowing these. Now, okay, we've got a modern building made up of planar surfaces, so flat surfaces. Figure B1 shows the plan and elevation, always a hint, okay, which is given first. It includes identical plane surfaces A, B and C. So these two are identical. Here it's also got a rectangular surface R, okay, and an equilateral triangular surface T. Okay, here are the coordinates for A, B and C. So across, up, down, across your page, up from your XY line, down from your XY line. Draw the plan and elevation of the identical surfaces A, B, C and A, B, D. No coordinate given for D. A, B is going to be an axis to mirror about. Let's have a quick look at this in 3D. So there's A, B, C. The X coordinate is how far it is from the end vertical plane. The Y coordinate is how far it is from the horizontal plane. So 0 means it's on the horizontal plane. And the Z coordinate is how far out from the vertical plane it is. Now we then mirror, alright, ABC to get ABD. We mirror over an axis line. Now here's our elevation of our planes ABC and ABD. So there you can see our elevation and then our plan view. Okay, right. Okay, we get started. So our YY line, our XY line, our A coordinate is over 20. Our B coordinate is 120. So B is 120. Okay, our C coordinate is 75. Then our A coordinate is up 0, down 30. So up 0, down 30. Okay, our B coordinate, okay, is up 90. So our B coordinate is up 90 from the horizontal plane. And it's down 80 from the XY line. So out 80 from the vertical plane. Okay, out 80. Now our C coordinate is on our XY line. It's 0, it's altitude for the Y axis, and then its Z coordinate, how far it is out from the vertical plane, is 95. Now this is C, B and A. So it was 30 for our Z coordinate, our C was 95 and our B coordinate was 80. Now, I'm going to join these A, B and C. Now our D coordinate is a mirror image of point C. So I'm going to line my set square up with line AB. Get my compass. I'm going to flip C over onto the opposite end of that line. So my D coordinate is going to be here. there's point D. Now, I can bring D up to our elevation. It's going to be on the XY line, same as the B or the C coordinate. Now, B to A, C to B, and then D to B. So that's part A done. So they just go up to B there. That's part A done. Determine the dihedral angle between the planes. Right. Here's your steps. 1. Find LOI, line of intersection. It's A, B. 2. Check for true length. So the line of intersection, okay, checks the true length. So if a line is parallel to the XY line in plan, it's a true length in elevation. If it's parallel to the XY line in elevation, it's a true length in plan. If it's a point in elevation, it's a true length in plan. And if it's a point in plan, it's the true length in elevation. Okay, our line of intersection is neither of them, so it's not a true length. We need the line of intersection to appear as a true length. So 3 is get LOI as a true length. TL for true length. 4, project along TL, true length. And the whole reason is because if you look along the true length of a line, it projects as a point. A line projects as a point. Line projects as a point when you look along its true length, and the surface or surfaces that contains the line projects as an edge view. And when two surfaces appear as edge views, you can see their dihedral angle. So we need to get this line of intersection, okay, AB, projecting as an edge. See, then you get the dihedral angle. You can see the two edge views of the surfaces projecting as, or two surfaces projecting as edge views, okay, in my model here. Now, unfortunately, you can't look, or you can look, unfortunately, you can look along a line in 3D to get it as a point, but you can't do that, okay, in 2D. So you have to find your true length and then look along your true length. Right. So I begin. So I'm going to line my set square up parallel to AB. I'm going to project the points A, B, C and D parallel or perpendicular to the line of intersection. I'm going to draw in, okay, an X1, Y1 line. It's the HP. And I'm going to take my heights from my elevation. I'm going to take my heights from elevation. So the only height I need to take is point B, because the rest of them are all on the XY line. So the height of point B from elevation, so I can take with my compass, yeah, like this, or I can just mark it up. The distance is 90. So I can mark 90 down there. This is B1. Now, here's C1, A1. Right, so I can join A1 to B1, C1 to B1, and also there is D1. Now, here's the line of intersection as a true length. So I can now look along this line of intersection and project a second auxiliary. So I can now look along this line of intersection and project a second auxiliary. So I draw in my X2, Y2 line there. So I can take my distances back from my X1, Y1 line back to plan. So the distance of A, B, find B here, just follow it down. So find B, follow it up here. There we go, same one. Now C, so I get the distance of C. Follow C along here. I mark it in. And then I'm going to do D. I'm going to mark D in here. So then I have, okay, C2, D2, B2/A2. I'm going to connect them together. Now, and then you can see our dihedral angle, 68.7. See, we're going to get our protractor. We're going to measure. We're going to get our protractor. We're going to measure it in. So there we go. Now, that's our A and B done. Now, we have, okay, to do part C. Complete the elevation and plan by drawing the equilateral triangle T and the rectangle R. Right, we'll start with the equilateral triangle. So 3 equal sides. This base that's hidden detail is a true length because it's parallel or on the XY line in plan. So this can be used now. It's fairly safe to assume that these are perpendicular. And look, the apex touches, alright, touches line AB. So here's how I'd approach this question. Okay, and my auxiliary is very useful to it. Now, I construct the triangle on the horizontal plane. Okay, I construct it on the horizontal plane. I bring it over to my auxiliary elevation. There's the plane or the triangle on the horizontal plane. So I bring it over to my auxiliary elevation. Here. Now, when the triangle is on the horizontal plane, it's on the x1, y1 line in our auxiliary elevation. Then I rotate it up until it hits the true length of the line of intersection AB. And here's the triangle getting rotated. There. So then, okay, I would bring this point, you're going to see now coming up. I'll bring that point back down to our plan view. And now we're going to have our plan view, okay, of this triangle. Sorry, I'm sorry about knocking that. Must be going too hard in the gym. Now, there's our plan view of our triangle, and then we can get our elevation. So, as I said, we're going to construct this lying flat on the horizontal plane. So, we're going to mark 15 and 15 here either side. Now, I'll bring this back. And now where it hits the edge there, I'm going to bring this back to my x1, y1 line. I'm going to get my compass. I'm going to set my compass to the length of 30, okay, in plan. Swing an arc. And swing an arc there. So this is it. This is the true shape of this equilateral triangle. TS. Now, I'm going to bring that back to my auxiliary elevation. And that's it on the x1, y1 line. I'm going to get my compass. I'm going to put my compass here. I'm going to rotate it up. Okay, till it hits up here, because you just know that that's right. Okay, because it's far higher. Now, I can join them together. And now I can bring this back to my plan view. I can project it back to my plan view. So here it is there. I can heavy this detail in. And then I can project that up to my elevation. And I can project the base points up as well. So there I have the equilateral triangle T drawn in elevation. Now, the rectangular surface R is next. Altitude 35 is the next Y line. So, if we go up, okay, 35 mil from our base, okay, where it intersects this line here, okay, B to C and B to D, it's going to give us points on this rectangle. that you can see right there in red, that's its traces. Here's the plane, it's going vertically down, and here's the rectangular surface. Here's the rectangular surface containing R. So we can put that in. So we just have to go up 35 in elevation to hit these edges. Okay, that's all we have to do. And the reason we know that is because in plan view, this rectangular surface is projecting as an edge view. So these two lines must be true lengths, like we were shown down here. So I'm going to go up 35. I'm going to draw a horizontal line across. Now, here's the elevation of R. And here's the plan view of R. Then I can finally do all my heavy and hidden lines in plan and elevation after I've established them all. Now, the last thing I have to do is find the traces of the plane that contains the surface B, C, and D. So surface B, C, and D. So I'll go through this on the model. So just hide my rectangular surface or hide a few of these sketches. Okay, this is just a bit too busy. Now, so here's the plane, oblique plane, BCD. Okay, the plane that contains points B, C, and D. Now, where this intersects, okay, where this plane intersects the vertical plane, we get the VT, where it intersects the vertical plane. So that's the VT there. And then when it intersects the horizontal plane, we get the HT. So that's what we're looking for, to find those lines of intersection. Okay, so how we're going to do it is we're going to realize that if points B and C are on the XY line elevation, they're on the HT, okay, in plan view. So I just need to join those 2 points together in plan view. Right, so B and C, C and D I need to join together, C and D, my bad. So C and D are points on the XY line elevation, so they're points on the HT in plan. So here's my HT in plan. Now, Parallel lines are parallel in every orthographic view. So I'm going to draw a line parallel to B, okay, in plan. And the VT is on the XY line in plan. Because the XY line is the VP. So here's a point on the VT. Okay, number 1 we'll say. And this is point E. Now I want to get the elevation at that point. Now I'm going to project this up. Now in plan view, I went parallel to the HT from point B. And the HT is on the XY line elevation. So I'm going to go parallel to point B, okay, in elevation. And now, here's point number 1, and that's on the VT. So I can join them together. And there's the VT in elevation, right? So I'll go through this. Okay, here, look, here's the construction. Here's a line in 3D on the oblique plane, parallel to the HT. Here's the elevation of this line, and they intersect at a point on the HT. So then, you get those planes, and that's the plan view, or you get those traces. That's the plan view of the line we were referring to. Now, I'll just pause there for one moment, and there's a CAD solution of the question. Some different methods in constructing it, but all the same answers. You can see the HT, the VT in the same position. You can see your dihedral angle, okay, the same angle. So, okay, that'll do.